Welcome to the recitation for Bioengineering 2020, LU Decomposition. The goal of LU Decomposition is to get our matrix in the form of L times U. L and U stand for lower triangular form and upper triangular form. And we have seen upper triangular form before in Gaussian elimination. That is where everything below the diagonal is zeros. So then lower triangular form is where everything above the diagonal is zeros. So this is the reasoning behind what we're doing. We can multiply each side by the identity matrix without changing the solution. So we're going to break the solution up into these elemental matrices, and they're going to be multiplied on the A side. Then we're going to take their inverse and put them on the U side, and the combination of them we're going to call L. So we're going to end up with A equals LU, where we started with E's times A equals U. So let's go through one of these to see how that works. We're going to start with the A matrix, and we do this by Gaussian elimination. Or forward elimination. And we're going to use this shortcut method. In another video, I'll go through the long way, but right now we're just going to keep track of the elemental matrices changes in these spots. And for the inverse, it's the negative of those elemental pieces. So our first step is to, as we mentioned before, it's Gaussian elimination. So we're trying to get this into upper triangular form. So we'd like a 0 in this spot. So what we'll do here is say 2 times row 1 plus row 2 goes to row 2. So our first row does not change. Our second row becomes 0, 16, and minus 1, because 2 times row 2, 2 minus 2 is 0. 8 plus 8 is 16. Minus 6 and 5 is minus 1. And then nothing changes with the row 3. Now we're going to get rid of this 3. To do that, our row operation is going to look like 3R1, 3 times R1 plus row 3, and that's going to replace row 3. So our first 2 rows are not going to change, and I'll copy those over. The last row will become 0, minus 8, and 16. And that is because minus 3 times 1 plus 3 is 0. Minus 3 times 4, minus 12. Plus 4 is 8, minus 8. And minus 3, that'll be 9. Plus 7 is 16. And our final step for the Gaussian elimination for this LU decomposition is to get rid of this minus 8. We're going to do that by taking 1/2 of row 2 plus row 3 and replacing row 3. We don't want to go back up to the first row because that's going to introduce this 1 back down into this column. So we're just going to go up to row 2. Okay, so the first 2 rows don't change. 4 and minus 3, 0, 16, and minus 1. And the third row is this is going to stay as 0. That is going to be a 0. And this is going to become 1/2, minus 1/2 plus 16, 15.5. So this is U, our U matrix, and this, and this are our echelon matrix factors. We were right here when we changed, let's see, oops, this is right here for the 2, so 2 goes right into that spot. Next we changed the 1, 3 position with a minus 3. And finally we changed the 3, 2 position with a 1/2. So 1/2 is going to go there. So this is our L. We have our L matrix here and our U matrix here. And so let me show you what that looks like. A equals L times U. So A is 1, 4, minus 3, minus 2, 8, 5, 3, 4, and 7. And that equals L, 1, 0, 0, minus 2, 1, 0, and 3, minus 1/2, and 1, times U, 1, 4, minus 3, 0, 16, and minus 1, 0, 0, and 15.5.